DRAM cells require periodic refresh cycles.
DRAM cells require periodic refresh cycles.
The capacitor structure limits further scaling.
The capacitor structure limits further scaling.
Cell-to-cell interference increases as scaling continues.
Cell-to-cell interference increases as scaling continues.
The design targets higher density per die.
The design targets higher density per die.
We need to review the cell design.
We need to review the cell design.
The trench capacitor depth determines storage capacity.
The trench capacitor depth determines storage capacity.
Buried word line technology reduces cell area.
Buried word line technology reduces cell area.
The bitline capacitance affects sensing margin.
The bitline capacitance affects sensing margin.
We're implementing a hierarchical bitline structure.
We're implementing a hierarchical bitline structure.
The sense amplifier sensitivity needs improvement.
The sense amplifier sensitivity needs improvement.
Cell transistor threshold voltage shifted after stress.
Cell transistor threshold voltage shifted after stress.
The array architecture impacts access time.
The array architecture impacts access time.
We're evaluating vertical transistor designs.
We're evaluating vertical transistor designs.
The cell aspect ratio is reaching physical limits.
The cell aspect ratio is reaching physical limits.
Word line resistance increases with scaling.
Word line resistance increases with scaling.
We need to optimize the cell layout.
We need to optimize the cell layout.
The storage node contact is critical for yield.
The storage node contact is critical for yield.
Capacitor dielectric thickness affects retention.
Capacitor dielectric thickness affects retention.
We're testing new high-K dielectric materials.
We're testing new high-K dielectric materials.
The cell design must balance area and performance.
The cell design must balance area and performance.
Retention loss becomes critical at higher temperatures.
Retention loss becomes critical at higher temperatures.
The refresh interval must be adjusted.
The refresh interval must be adjusted.
We observed retention failures in long idle states.
We observed retention failures in long idle states.
The margin is insufficient at low voltage.
The margin is insufficient at low voltage.
Temperature acceleration worsens retention behavior.
Temperature acceleration worsens retention behavior.
Data retention is temperature dependent.
Data retention is temperature dependent.
The refresh rate limits power efficiency.
The refresh rate limits power efficiency.
We're seeing retention tail bits in every die.
We're seeing retention tail bits in every die.
Retention time varies across different cells.
Retention time varies across different cells.
The auto-refresh mechanism needs optimization.
The auto-refresh mechanism needs optimization.
Weak cells require more frequent refresh.
Weak cells require more frequent refresh.
We need to identify retention fail bits early.
We need to identify retention fail bits early.
The retention specification is 64 milliseconds at 85 C.
The retention specification is 64 milliseconds at 85 C.
Variable refresh rate can reduce power consumption.
Variable refresh rate can reduce power consumption.
Retention screening eliminates weak dies.
Retention screening eliminates weak dies.
The retention distribution shows a long tail.
The retention distribution shows a long tail.
We're implementing targeted row refresh.
We're implementing targeted row refresh.
Capacitor leakage dominates retention failures.
Capacitor leakage dominates retention failures.
The retention margin decreased after burn-in.
The retention margin decreased after burn-in.
Self-refresh mode extends battery life.
Self-refresh mode extends battery life.
Row hammer effects degrade data integrity.
Row hammer effects degrade data integrity.
This issue impacts long-term reliability.
This issue impacts long-term reliability.
ECC masks most single-bit failures.
ECC masks most single-bit failures.
The failure rate increases beyond spec.
The failure rate increases beyond spec.
Leakage current increased after the stress test.
Leakage current increased after the stress test.
We're implementing row hammer mitigation techniques.
We're implementing row hammer mitigation techniques.
Victim cells show reduced charge retention.
Victim cells show reduced charge retention.
The row hammer threshold decreased at advanced nodes.
The row hammer threshold decreased at advanced nodes.
We need to track activations per refresh window.
We need to track activations per refresh window.
Adjacent row activation causes charge loss.
Adjacent row activation causes charge loss.
The mitigation logic adds latency overhead.
The mitigation logic adds latency overhead.
We're testing probabilistic row hammer solutions.
We're testing probabilistic row hammer solutions.
The failure mechanism involves hot carrier injection.
The failure mechanism involves hot carrier injection.
Row hammer becomes worse with technology scaling.
Row hammer becomes worse with technology scaling.
We need system-level error correction.
We need system-level error correction.
The DRAM specification includes row hammer limits.
The DRAM specification includes row hammer limits.
We're characterizing row hammer on every design.
We're characterizing row hammer on every design.
Repeated access patterns trigger the vulnerability.
Repeated access patterns trigger the vulnerability.
The defense mechanism increases refresh overhead.
The defense mechanism increases refresh overhead.
We need to balance security and performance.
We need to balance security and performance.
Operating voltage reduction improves power efficiency.
Operating voltage reduction improves power efficiency.
The voltage margin shrinks at lower supply.
The voltage margin shrinks at lower supply.
We're testing operation at 1.1 volts instead of 1.2 volts.
We're testing operation at 1.1 volts instead of 1.2 V.
Power consumption scales with frequency and voltage.
Power consumption scales with frequency and voltage.
The low power mode reduces refresh current.
The low power mode reduces refresh current.
Voltage droop causes timing failures.
Voltage droop causes timing failures.
We need better on-die voltage regulation.
We need better on-die voltage regulation.
The power delivery network impacts performance.
The power delivery network impacts performance.
Voltage scaling is limited by retention requirements.
Voltage scaling is limited by retention requirements.
We're implementing dynamic voltage scaling.
We're implementing dynamic voltage scaling.
The standby current exceeds specification.
The standby current exceeds specification.
Power gating reduces leakage in unused banks.
Power gating reduces leakage in unused banks.
We need to characterize operation across voltage corners.
We need to characterize operation across voltage corners.
The voltage reference impacts sensing accuracy.
The voltage reference impacts sensing accuracy.
Temperature and voltage interact on retention.
Temperature and voltage interact on retention.
We ran retention tests at multiple temperatures.
We ran retention tests at multiple temperatures.
The wafer-level test coverage needs expansion.
The wafer-level test coverage needs expansion.
We're seeing systematic failures in specific locations.
We're seeing systematic failures in specific locations.
Package-level testing revealed thermal issues.
Package-level testing revealed thermal issues.
The burn-in screen eliminates early failures.
The burn-in screen eliminates early failures.
We need to add functional patterns to test flow.
We need to add functional patterns to test flow.
Speed binning separates fast and slow dies.
Speed binning separates fast and slow dies.
The test time directly impacts production cost.
The test time directly impacts production cost.
We're implementing built-in self-test logic.
We're implementing built-in self-test logic.
Parametric measurements show voltage dependence.
Parametric measurements show voltage dependence.
The correlation between wafer and final test improved.
The correlation between wafer and final test improved.
We need to characterize across process corners.
We need to characterize across process corners.
The test escape rate is too high.
The test escape rate is too high.
We're adding stress tests for row hammer.
We're adding stress tests for row hammer.
The characterization data guides design improvements.
The characterization data guides design improvements.
The yield ramp is ahead of schedule.
The yield ramp is ahead of schedule.
We identified a systematic yield limiter.
We identified a systematic yield limiter.
The production volume increased last quarter.
The production volume increased last quarter.
We need to improve die per wafer count.
We need to improve die per wafer count.
The scrap rate decreased after process optimization.
The scrap rate decreased after process optimization.
We're transitioning to volume production next month.
We're transitioning to volume production next month.
The yield learning curve matches the model.
The yield learning curve matches the model.
Customer returns point to a latent defect.
Customer returns point to a latent defect.
We need tighter specifications for this application.
We need tighter specifications for this application.
The product qualification is complete.
The product qualification is complete.